Welcome to the day 9 of the 100 Days of Python Code Along with Me series. And today we're going to extend a little bit on what we learned on day 8 with the turtle. As a reminder, if you want to download the sample code or get access to the entire listing of these videos, you can go to my website, www.bmosley.com/hdp. And that'll take you there. And you can also download the sample code for a lot of these exercises. So if you want to go there, that's how you get to that location. Okay, so before we jump into our coding exercise for today, there's a couple of things that I want to show you related to the turtle, and sort of by the way of that, also related to importing modules. And last time we used the turtle, we used import turtle, and that works fine, except that anytime we want to reference the turtle, we would have to you do something like this, and then we would say turtle.forward. And if we wanted to shorten that, um, we could say t equals turtle.turtle to create an instance of the turtle as t, and then we would say t.forward and so on. But there's actually a simpler way to do this, and I just want to show you this trick because it is a nice shortcut in certain scenarios. So if I want to import those turtle functions as sort of native Python functions, if you will, I can say from turtle import star. And what that means is import all of the modules, all of the functions, all of this constants, everything that's part of the turtle module, import that. Import all of it. That's what this character typically means. Aside from multiplication, it also stands for a wildcard, which means import everything. But when I say it this way, what it does is it allows me to skip the turtle dot part of that. So I can now just say forward 100. And if I say done, which holds that window open for me, and I run that, then I have the turtle going forward and a lot less typing. So that's kind of a nice thing to do. So we're going to play around with that a little bit. But the other thing that I want to show you is a command called teleport. And if I say turtle.teleport, I can do that. But now I don't need to do that, right? Because I did the from turtle import wildcard. So I can just say teleport, and teleport wants x and y coordinates. So we're starting out at 0, 0, and I'm telling it to just go to that place. So it won't draw a line, it'll just jump from one to the other, just like the name suggests. So when I run that, oops, forgot to hold the window open. Easiest way to do that is to type done at the end there. You can also do the screen.exit on click, but this is the easiest way to do it. So now I've got turtle, and it teleported to the home position, which is straight here in the middle. Now, using a combination of positive or negative values for x and y, I can move to different places. So let's do a little exploration of those positive and negative values. So if I say 300, comma 300, so x value of 300, y value of 300, then the turtle teleports to 300, 300. This square appears to be about 800 by 800 total. So we've got 400 in this direction. And let's just verify that. We'll just go 400, comma 400. And we can see there, that's a little bit beyond 400, but that's kind of close to the end. And if I wanted to do negative 400 by negative 400, then I'm going to get the turtle down in this corner. So if I go a positive x and a negative y value, then I get this corner because positive x is anything on this side of the middle. So that's positive x, negative x is over here, positive y is up, negative y is down. So those are the four, sort of how to get to the four corners of the default screen. And teleporting the turtle is a nice way to move the turtle without drawing a line. And in our previous code, we did something a little bit different. What we did was we did a pin up, and then we moved the turtle using forward, backward, and so on, and then pin down. But what you'll see as I preview the code that I've created here is that I've switched to teleport. So I wanted to introduce you to that. And there's one more fun thing that I wanted to show you before I leave this little demo screen, and that is shape. And the fun thing you can do here is change the shape of the turtle. And one of the options is actually a turtle shape. So now the turtle can look like a turtle. So that's kind of fun as well. So that's just another fun thing you can do with turtle. But there's all kinds of turtle commands that you can look up. And the resource for that is right here in the Python docs. But if you just Google Python turtle docs, that's a great way to find this document. And this gives you an exhaustive list of all of the things that you can do with the turtle, okay? As well as some nice sample code. And it is more advanced. It does get more advanced pretty quickly than where we're at in this series, but gives you plenty of things to play around with. So let's get back to our code here, and let's get back to our main code. And if this is the starting code that you can download from the website, and this code actually finishes what we started in week 8, and this actually writes the word Python on the screen. So if I just demo this, and I've got the turtle speed turned all the way up to 10 here, so it'll go rather quickly. But if I run that code, there is the Python, and I'm going to apologize to all of the people who have typography education. I know it's kind of weak, but there it is, and that is at least recognizable as letter. And so each one of these pieces of code here, you can see is commented to say what it does. And as I get into some of these, I start using some other commands and I use teleport to move the turtle easily. And what this part says, this code right here, says teleport, and then it uses the current x coordinate. So x core is its current location, and then it is plus 70. So it adds 70 to the x and moves it essentially 70 spaces to the right. So if I go back really quickly to that file that I was playing around with, just so we can kind of see how this works, if I teleport to 300, 300, and then I print the x coordinates, and I print y core. You can see here, let's run that current file. And there is the turtle location, and then it prints 300 here and 300, which are the x coordinate and y coordinate. So if I say teleport, and let's say I want it to move down 50 pixels. So if I do teleport to y equals, okay, so I'm specifying the y coordinate here. I want to say y core minus 50. That'll move it down 50. And then let's print the y coordinate again. Y core. Let's run that and see what we get. Okay, so there is my turtle. It was here, right? About 50 pixels from the top and the right-hand side. And then it moves down actually rather about 100 from each, and then it moves down 50. You can see here it prints 300, 300, and then when I reprint the y-coordinate after moving it, it goes to 250. So that is how that works in terms of moving the turtle. So when I look at that in this code, you can see here, this takes the x-coordinate, adds 70 to it. Note the reason I don't have to say x equals here is because the default first argument for teleport is the x-coordinate. So I don't have to name that. I could for clarity. In fact, I'll just leave that one there. So that's what it looks like. If I wanted to specify the y-coordinate, then I would have to specify y. Okay. So again, we're just moving along that horizontal line. And a little bit later, you can see here, when I start the O, the reason I start the O is because it doesn't start drawing the O on the baseline. It starts about halfway up the O on the left-hand side. So I want it to go about 30 pixels off of that baseline. I want it to go up about 30. And then the x-coordinate is its current coordinate plus 80. So it's moving over and up a little bit. And then when it draws the O, it actually starts on that left-hand side, draws the top half, and then it draws the bottom half. And then you can see it teleports 70 pixels to the right and back to the baseline, which is 0. So that's kind of how it's drawing the word Python. Each letter is kind of drawn individually, and there's a lot of extra code here, a lot of repetitive code here. And yes, in case you're wondering, there is a better way to do this. But the simplest way to do this is by drawing each little segment explicitly. So here's what I want to do. I want to take this and I want to use a variable that will scale this whole word to bigger or smaller. Okay, so what I'm going to do here is I'm going to write int size, and the current size, the 100% size, will be 10. So if I want it to stay its default size, it's going to be 10. And I'm going to let it go up to 20, which would be double the size. And I'm going to let it go down to 1, which is its smallest size, or 10% of its current full size. So we're going to scale this whole thing. And the way we do that is we're going to create a scale factor. And the way we do that is FL scale. And the reason it is a float is because it's going to be a decimal number. Okay, so scale is going to be int size over 10. So if I go up to 20, you can see it's 2 over 1, or 200%. And if I go down to 1, then it becomes 10%. So now I need to take this scale variable and I'm going to multiply it times every piece of this code where I've specified a distance. So in other words, the angles are not going to stay the same. I mean, the angles are not going to change. We don't scale angles. What we scale is distance and size. And so when I go backward, now I'm going to go backward times FL scale. So it doesn't go as far during that piece. So now I'm going to take that and I'm going to copy that one piece of code, and everywhere there's a distance measurement, I'm just going to paste that in. So I'm going forward here. The radius of the circle is a distance. So I'm going to paste that there. And it's just going to multiply that times the scale everywhere it goes. So I am just going through the code backward. Yes, we want to scale that. We're not scaling angles. We're only scaling movement, because the angles stay the same. The shapes are the same. We're just using a different proportion. So I'm going through my code and I'm literally just adding that scale everywhere it goes, because I want it to change each thing. Even the distance between letters needs to scale. So anytime I move, I'm scaling the distance that I move. Okay, so this is a little tedious because there's a lot of lines of code. But once I get this done, you're going to see something pretty cool. So I'm on the H now, going through and literally just scaling each little piece of this movement forward, all of the circle radiuses. Okay, just making sure that I don't miss anything here. Teleport. Now I could put the distance, I could put FL scale here, but it's always going to be 0, so it's sort of irrelevant because 0 times anything is always 0. But I got to get that circle radius and all of the forward pieces. If I miss one of these, it's going to become really obvious really quickly because my shape is going to be off. So let's run this, and hopefully it will draw the same exact shape that it did before. So let's check it out. Okay, same shape, same size. So far, so good. Now, to test this out, I want to try, let's make it half size. So I'm changing the 5 to a 10, which means everything here is going to be multiplied by 50%. So let's run that and see. Looking good so far. And there's my 50%. Will it scale larger? Let's go full 200%. I don't even know if that'll fit properly, but let's just do it anyway. All right. Looks like it's going to fit exactly on the page. It's almost like I planned that. I promise I didn't, but wow. Okay, so there it is. It fits exactly on that page. Interestingly enough, this is a really a very, very basic analog to how fonts work and font sizes. When we scale a font, it's literally a mathematical formula that draws the font using the same angles with different proportions on the page. So there's some really interesting things going on here that sort of apply to other areas of computing. But that is how we would use a variable to very quickly, you can see I'm changing all of these values at once because they're all connected to this one variable, which is composed of that times 10 or divided by 10. So that's it's a great powerful demonstration of variables and how you can use variables in your code to change different values. And that's using a turtle to create a scalable design.